This tutorial demonstrates advanced methods for constructing node sets and side sets in Cubit. Specifically, by the end of this tutorial, you will be able to construct a node set that includes all the nodes on the exterior of a geometry, as well as exclude nodes based on different criteria. This tutorial makes use of command line entity specification and filtering. Documentation for the entity specification and filtering can be found in the environment control, entity selection and filtering. The command line entity specification describes topological selection, which is done using the in keyword. The extended command line entity specification describes selection by criteria, which is done using the with keyword. Using these two keywords, we can create powerful commands to select entities in Cubit. In this example, we will create a simple heatsink type geometry. It is important to note that this geometry is composed of two volumes that have been merged along the internal surface. This surface is highlighted here. The geometry is also meshed with an all-hexahedral mesh. When creating node sets and side sets, it is important to remember that Cubit utilizes both geometry-based and mesh-based selection. In this example, if we want to create node set 1, we can select a surface and select that surface that was between those two volumes. Here we'll use the select other to find that surface that is between the two volumes. Hit the apply to create the node set. If we go to the tree and open up boundary conditions, finite element analysis, and look at node set 1, we can see that all of the nodes in node set 1 are highlighted. If we wish to add additional entities to the node set, in this case, selecting volume 15 at the bottom, we can see that all of the nodes in volume 15 are added to that node set. Both the nodes on the exterior and the interior. Now we can remove volume 15 from that node set, and when we look at the tree to highlight the nodes, we can see just surface 2 exists in that node set. We can also remove surface 2 from the node set. When we do that and highlight the node set, we see that there are no nodes that currently exist in the node set. Using entity specification and filtering, we were able to create complicated node sets and side sets. For example, to create a node set that contains the nodes on the exterior of the geometry, we use the with expression. In this case, we are going to select all of the surfaces with not is underscore merged. The is underscore merged keyword indicates that if an entity is merged with another entity. By using the not, we select all of the nodes that are on the exterior of the model. It is also possible to use extended entity specification and filtering to remove geometry from a node set. In this case, we will select the nodes and remove all of the nodes that are in surface 141, using the in keyword to do the topological selection. Now, when we look at the model, we see that there are no nodes in that bottom surface in the node set. Although node sets and side sets can be generated and manipulated using mesh entities, in general it is easier and more efficient to work with the geometry components. Another example of extended entity specification and filtering is to add and remove nodes based on their location. For example, by selecting with x coordinate less than or equal to -4.9, we can remove all the nodes along one side. Multiple criteria can be combined together so that we can remove all of the surfaces that are not merged and with an x-min value less than 0. Entity selection and topology criteria allow powerful methods for specifying boundary conditions in Cubit. That concludes this tutorial.